Welcome everyone, whether or not you're joining from the West Coast, the East Coast, from international, welcome to this evening's webinar. Here at Women Who Code, we're going to go ahead and give an introduction. My name is MK Comer. I am a Women Who Code Leadership Fellow. I help facilitate all of the front-end events. Here joining us, we have Rachita. She is a software engineer at Microsoft, here to do a workshop on Introduction to React Hooks. In this course, we will be going over the standard built-in hooks provided by the library and demonstrate their working with small examples. A couple of logistics for this webinar. As I've said, feel free to introduce yourself via the chat and where you're joining us from. It's always exciting to see where all of our community and our members are joining from. We will be doing Q&A at the end via Zoom Q&A, so feel free to submit your questions as you come up with them, and we will save 10 to 15 minutes at the end of the webinar to get those questions answered. And as always, all of our webinars are being recorded and they are posted to YouTube about a week after the event. Following the webinar, I will be sending out Rachita's contact information as well as a link to our Women Who Code YouTube. And that is where you can find all of our webinars, and you can anticipate to see this webinar posted about a week from now. That being said, whether or not this is your first webinar with us or you've been on many webinars with us, welcome. Our mission at Women Who Code is to inspire women to excel in technology careers. And we envision a world where women are representative as tech executives, founders, VCs, board members, and software engineers. Here at Women Who Code, we have an inclusive community and a strict code of conduct. This event and all of our events are inspired for women to excel in technology careers, and anyone who is here for that purpose is welcome. We do not tolerate harassment of members in any form, and our code of conduct applies to all Women Who Code events and online communities. That being said, our events are dedicated to providing an empowering experience for everyone, regardless of gender, gender identity and expression, sexual orientation, ability, physical appearance, body size, race, ethnicity, and we often like to joke, preferred programming languages. Our target here are engineers with 2 or more years of experience looking for support and resources to strengthen up their influence and level up their careers. And our movement and our commitment to you all is, as the world has changed drastically in the last year, we hope we have been a connecting force that creates a sense of belonging as the entire world has been asked to isolate so much this last year. So thank you so much for being part of this community, and I hope it's truly provided a connecting force for you all. Just at the end of 2020, we hit 250,000 members throughout both our in-person networks as well as our digital networks. We have 70 networks in 20 different countries and members from 120 different countries around the world. We've to date put on about 2,000 events annually, and when conferences are back in session, we typically hand out over $1,000 daily in conference tickets and provide $2 million worth of scholarships for various different resources. And we also provide access to jobs and infinite connections. If you're not signed up, we do have a newsletter, a weekly newsletter that does provide resources to jobs as well as different scholarships and different events that you might be interested in. So feel free to sign up for our newsletter via our website. Tonight, we are here with Women Who Code front end, but we do have 5 other technical tracks that were launched in 2019. So if you're interested in front end, but you'd also be interested in data science, mobile, blockchain, Python, or cloud, feel free to check out any of these tracks. Similar to the front end track, each of these tracks is designed to provide tech talks, workshops, tutorials, and trainings, as well as technical study and project groups. We also have different panels, fireside chats, workshops like this evening, and networking opportunities, as well as access to the latest coding resources and other women who are interested in doing different project support and knowledge sharing in general. You can check out the other tracks at womenwhocode.com/digital. As a lot of our in-person events have tried to migrate over to our digital tracks, feel free to check out any of those other tracks. Additionally, if you're interested in getting involved just beyond attending our webinars, we're always interested in having more volunteers. You can reach out to me directly at mkcomer@womenwhocode.com, or you can reach out to fellows@womenwhocode.com. Each other leadership fellow runs all different tracks. So if you're specifically interested in working with any track, you can reach out to any of those emails listed below. We are looking for speakers. We are looking for speaker facilitators to help find speakers. We're also looking for various volunteers to support social media as well as our Slack channels. So if any of this is of interest to you, feel free to reach out to me directly. Additionally, if your company is interested in partnering with us and putting on a webinar or posting to our job board to get access to our community, you can reach out to our sponsorship team at partnerships@womenwhocode.com. And without further ado, we would like to give Rachita a very warm welcome. Rachita is a software engineer at Microsoft, and here she is talking to us about an introduction to React hooks. Welcome, Rachita. Thank you so much for being here with us.
Thank you, MK. Hello, everyone. I'm Rachita Bansal, and I'm a software engineer at Microsoft. And without much ado, let's get started with introduction to React hooks. Let me just pull up my slides there. Okay, are you able to see my slides?
Yes, looks good.
Okay, awesome. Okay, today I'm going to talk about introduction to React hooks and how to use built-in hooks in React components. So let's get started. Just to brush up on the basics, let's briefly go over what's React. React is a declarative, efficient, and flexible JavaScript library for building user interfaces. It hides the implementation details of DOM nodes and how they are created and interact with each other, while letting the developer compose complex UIs from smaller, isolated pieces of code called components. This is how a component looks like. It's a function that takes in a single argument called props and returns a React element, which in this case is a div tag containing the text "Hello World." React then takes care of rendering it on the UI. This component is called a dumb component as it simply gets the props and displays the data. But in general, UIs are dynamic in nature and need to perform actions like updating the state, running side effects, or accessing DOM elements. Previously, doing this was only possible in React from class-based components. These components would use special feature of React to keep track of data and update it reactively. That would make the UI components interactive. And it would look something like this counter example in our GIF. It uses the counter component here that keeps track of the count using this.state and an on-click handler called increment that would update the state using this.setState. Whenever the this.setState is called, React re-renders the component with a new value of count. This approach came with a few caveats. For example, class-based components won't let us share state logic for updating counter outside of the class. And previously, in order to share any logic across components, we'd have to wrap them with special functions called higher-order components that would soon grow in number as our app becomes larger. And it would become this huge tree of components, which is termed as a wrapper hell. Also, there is a considerable amount of template code that has to be written down to create class-based components, even for an element as small as a div containing text. To overcome these drawbacks, hooks were introduced in React. So let's see how this code is transformed using hooks in function components. Our previous example just gets reduced to 10 lines of code here. That's a lot less template code. And in this example, our counter component is using an inbuilt React hook called UseState. You can think of count and set count returned by UseState as state and set state in class-based components. And finally, Our component returns a div element to show the count value and the button that increments the count. What are React hooks? Hooks are special JavaScript functions in React that can be called from within a function component. You can think of it as a low-level primitive of React library that has special features such as managing the state, running the side effects, and so on. A hook must start with the prefix use, and React lets you create custom hooks using this notation. For example, like I have here, use cake, use frosting, use bake, use pastries, and what have you. This differentiates a hook from a normal JavaScript function and lets React identify and apply a special feature of hooks to it. Now, there are two main rules of hooks that you need to remember. Only call hooks at the top level. Don't call them inside loops, lists, or nested functions. And second, only call hooks from React function components or custom hooks. Now let's look at the examples. In this example, a hook is called inside an if condition. Now this is an incorrect usage. Remember, hooks can only be called at the top level, and React will throw an error in this case. Let's take another example. In this example, a hook is being called inside a callback function. This is again incorrect and will throw an error because hooks can only be called at the top level from function components. Let's see a valid example. Here, a hook is called at the top level of the function component, which is correct. Let's see another valid example. Here, a hook is being called at the top level of a custom component called useDom, which is a correct usage. Now let's jump on to built-in hooks. React provides some built-in hooks for performing actions like manipulating the state using UseState, running side effects using UseEffect, or accessing the context using Context API with UseContext. And there are some other additional hooks like UseReducer, UseCallback, UseMemo, which we'll go over one by one. Let's look at what each one does, starting with UseState. The purpose of UseState is to handle reactive data. Any data that changes in a component is called state. And whenever the data changes, the state needs to be updated reactively and reflect the changes in the UI. It returns an array of two elements, which is state, that is the updated state, and setState, which is the setter function called setState here, that updates the state reactively when the data changes. It optionally takes an initial argument called initial state, which sets the default state. The array format here is used so that we can destructure the array using JavaScript and rename the elements to whatever we want. Let's see a demo. Here we have a counter which is initialized to 0. And it's updated by 1 whenever I click this button increment. And similarly, there's a decrement button which reduces it by 1. Let's take a look at how we implement this using UseState. In our component called counter, we are using the UseState hook, which returns two elements, count, that keeps track of the current value of count, and a setter function called setCount to update the count value. The function returns a div element containing the updated count value and the two buttons with an on-click handler. Now the count is initialized to 0 by passing the first argument to UseState. When the button is clicked, the on-click handler callback called increment calls the setCount setter function, which updates the count and causes the component to re-render with the updated state. React then takes care of updating the UI with a new value of count. which is what we are seeing in our demo here. Let's move on to the next hook called UseEffect. This hook is used to run side effects in a function components. Remember, in class-based components, this was possible using lifecycle methods such as component did mount, component did update, or component will unmount, each of them being separate functions running at different times during the render phase. Now, these actions are accomplished in function components with a single hook called UseEffect, and it's used to run asynchronous code such as API calls, timers, mutations, subscriptions, etc. It takes in an inline function as its first argument, and optionally, you can return a cleanup function that runs after the effect is completed. UseEffect is fired whenever the state updates and the component re-renders. And it optionally takes an array of dependencies as its second argument. By changing the combination in the dependency array, you can emulate the behavior of lifecycle methods in the class-based components. So for example, if we passed an empty array as the second argument to UseEffect, it'll behave as component did mount and run only once after the component mounts. If no array is passed as a second argument to UseEffect, it will behave as component did update in class-based components and runs after every state update. And finally, a cleanup function can be returned from the effect, which is run after the effect completes, and can be used to run any teardown code like in component will unmount. This is a simple counter example using UseEffect. We have a counter that updates on click of a button. So I click, click, click. It's updating the counter value by 1. Here, the counter component is called it uses UseState hook that is initialized to 0. So the counter value at the beginning is 0, and it returns a count that keeps track of the updated count value and a setCount function, which is called each time when the button on click is clicked. We also have a UseEffect hook that updates the value of the document title after each state update. Note that we don't pass it a dependency array, so this UseEffect will run each time the state is updated. Let's verify using some console logs here. So we expect a current value of title to be 6. That's right. So our document title already has the latest value of count, which means that the effect ran after every update of count. Now let's jump to our next hook called UseContext. UseContext hook provides a way for us to connect our component to the context API that React provides. Context API in itself is a way to access global state objects across disconnected or deeply nested components without passing props to the child components. UseContext takes in the context objects as its first argument and returns the current value of context that's provided by the provider. In addition, it also lets the component subscribe to the context value changes. So each time the value updates, the component will be re-rendered. Earlier, we'd use a consumer component for accessing global states in a child component. But with UseContext, we can directly consume the context without using the consumer component. Note that the provider is still needed to pass the context value down to the children. Let's see an example. Here is a simple themed app, and the theme is globally applied using the context. And whenever the theme changes, we'd expect all children components using the theme to update with a new theme. For example, if I toggle the theme from light to dark, the button below the toggle gets updated with a new theme and reapplies the styles which are reflecting here. Now let's see the code for this. We use the context API and create a theme provider that sets the initial theme context and provides the value of theme down to the child component. Now, a component called themed button somewhere down in the component tree is consuming the theme context value using UseContext hook. And it's styling the button background and color using the theme value. Now, whenever the theme context updates at the top level in the app, the UseContext hook re-renders this component with a new theme, which is what we are seeing in the demo. Now, we have covered three main hooks that you'd almost always use when you're building a React app. But let's look at some additional hooks that React provides. UseF allows you to keep a mutable state which points to the same reference between renders. Think of it as having a state that updates the value but doesn't re-render the component. It takes an initial value to set as the default value and returns a mutable ref container with a property called current. This hook can be used to access DOM elements or storing mutable instance fields. Let's take a look at this with an example. Here is a simple timer app with two buttons, start and reset. Clicking on the start, the timer starts and keeps incrementing the count every 1 second. Pressing on the reset, the timer unsets and runs the cleanup function. So how do we implement this? Let's look at the example. We have a component called interval ref, which takes in three props: set clean, set count, and count. Set clean runs the cleanup function on unmount. Count keeps track of the current value of count, and a function called set count updates the value of count. Inside our UseEffect, we are using a JavaScript set interval function. We pass it an inline function that will run repeatedly every 1 second, which is calling the set count. And we also return a cleanup function that will clear the timer on unmount. Note that we pass an empty array to the UseEffect, and it will only run once. That is after the first render, because if we pass an empty array to the UseEffect, it behaves as component did mount. Finally, the component returns the updated count value that we saw in the demo. This should work, right? But there is a problem here. Since we pass an empty array to the UseEffect, it only runs once. And the closure in the set interval always references to the same count value, which never gets updated. So the counter remains at 1 even though the set count function is being called every 1 second. Here's what we can do. We define a mutable callback ref that closes over the fresh props in state. So we want to be able to update the callback ref with the new value of count on each state update, but we only want to call our set interval once. That is when the component mounted. So we'll write a new UseEffect which will run after every state update and update the callback ref whenever the count value updates. And this mutable callback ref now points to the latest set interval callback here inside this UseEffect. And that is it. That's how you can create your own timer component using ref and UseEffect. With hooks, we can eventually move all of the ref and the UseEffect logic into its own custom hook, independent of the component, and use it across all components. Finally, this example looks like this. Let's jump to the next one. UseLayoutEffect. UseLayoutEffect is very similar to UseEffect with the same function signature and functionality, but it differs in when it's applied. For the most part, React folks recommend using UseEffect because LayoutEffect runs synchronously after DOM mutations, blocking the visual updates, which can make the UI jarring, and that may not be what the user wants, and hence it should be used cautiously. Let's see what UseLayoutEffect in action looks like. This example is a little contrived, and we might never do this in real life, but it's just showing how synchronous updates are applied to UseLayoutEffect. We have a count state here and a button, which when clicked, tries to set the count to 0. Now, because it sets the count to 0, the state updates and the component re-renders, the UseLayoutEffect runs, and it sets the count back to pi. So if I try doing this, it just keeps setting the count to pi. But if you noticed, the intermediate state when the count is set to 0 is not seen in the UI at all. This is because UseLayoutEffect fires synchronously after the DOM mutations. Updates inside UseLayoutEffect are flushed synchronously before a browser has chance to paint. This can be useful for reading layout from the DOM. It becomes more clear when we compare this with UseEffect here. You'll easily see that there is no flicker happening when using UseLayoutEffect since it's blocking the visual updates, whereas UseEffect is non-blocking, and for a split second, we see an intermediate state on the UI. The next hook we are going to talk about is called UseReducer. It's similar to UseState hook and returns updated state, but instead of returning set state, it returns a function called dispatch. Instead of updating the store directly, dispatch function dispatches an action to update the state that takes in an object having a property called type, which is an action type, and an optional payload. The UseReducer function accepts an argument called reducer. The reducer is a function that keeps track of the current state based on the actions dispatched by the dispatcher. And this is also how Redux reducer works. And it can optionally also take two other arguments called initial args for passing the initial state and the init function that calculates the state lazily. The init function lets you initialize the state outside of the reducer and can come handy for resetting the initial state later. For the most part, you should be using UseState hook, but if you need to trigger deep updates and there are too many interrelated states in your component, such as the next one is dependent on the previous one, this is the hook you would want to use. Let's look at an example usage of UseReducer. We have a notes app here which can add new notes and delete previous notes. So if I add a new note and click on add, it adds new notes. And if I click on remove, it will remove the last one. Now let's look at the code here. The Notes app component returns a Notes toolbar and a list of elements that maps over the Notes list items. To keep track of the notes, we add a reducer hook called UseReducer to our component. The UseReducer hook takes in a reducer and an initial state. The initial state has two notes already. And the reducer function is passed two arguments, state and action. Based on the action type, it returns the new state. For example, if the action type is add, it'll add the payload to the state and return the new state back. Our UseReducer hook also returns a dispatch function, which we'll then use in our onClick handler to dispatch a user action for adding or removing the note. Finally, we define a ref value that keeps track of the input value. That always points to the latest text when calling the dispatch function. This completes our Notes app using UseReducer. Now let's move on to the next hook called UseCallback. When you define a callback function inside a component, it's always recreated whenever the component re-renders. By passing the function to UseCallback, we can memoize the function. It takes in the function itself as the first argument and a dependency array as its second argument. The function reference will now only change when any of the dependencies in the dependency array changes. A good use case for using it is when passing callback as props to child components to avoid unnecessary re-rendering of the children. So let's look at an invalid and a valid example. In this example, the onClick callback is being memoized with UseCallback hook and assigned to a button element. This optimization is not worth it because the cost of optimization is more than optimization itself. Since we are creating another function called UseCallback and passing it to dependency array, which in itself is more expensive than recreating the function each time. However, if we replace the button with a huge list and we don't want to re-render this list if the parent component re-rendered for some reason, we can optimize on the unnecessary re-renders of the list component by using React Memo and UseCallback together. React Memo is a function, wraps a function component based on the props passed to it. It's very similar to the pure components and class-based components. And using UseCallback makes sense here as the onClick callback now points to the same reference across renders of the component, and the memoized list component will get the same callback props, preventing the unnecessary re-renders of the huge list component. This GIF here shows the optimization using UseCallback and React Memo together. You can see that the memoized card only renders once and saves some unnecessary re-renders for us here. UseMemo is similar to UseCallback, but it optimizes on the computation costs of evaluating a value instead of a function for performance improvement. But keep in mind that we don't want to prematurely optimize on performance, and therefore React provides this as an opt-in feature to apply the optimization where you know that it's hurting the performance. It takes in an inline function that returns computed value as its first argument and an array of dependencies as its second argument. It will recompute the value only if the dependencies change. And if no dependency array is passed, the value is recomputed on every render. Remember that UseMemo is just an optimization, and so you should write the code that works without using UseMemo and later optimize for performance. Here's a sample app that takes in a search input text and filters search results based on the input value. A list of elements based on the search input is displayed to the user. So for example, if I add a search filter mount here, I get a single result. So let's look how this is implemented using UseMemo. So we have an input text state for the user input and a search input state for the search filter. The onChange input handler sets the value of the input field whenever the user types in a text. And the onClick handler sets the search filter value when we hit the search button. Then we have a search results function which filters the list based on the updated search filter value. Now what's happening here? Let's see. The component re-renders every time the input text state updates and once every time when the search filter state updates. Notice that we are computing the search results on each render. And imagine if our list was very huge. We can optimize on the computation for calculating the search results using UseMemo. Now we pass a dependency. We wrap our function inside UseMemo and pass it to an additional dependency called search input, which is a search filter state. A search filter will now, our search results will now only be computed if the search input value changes and not on every render. This is how we can save expensive computations in between of our renders in the component. UseImperativeHandle. UseImperativeHandle is used to customize the instance value that's exposed to the parent component using refs and can be used with forward refs. Forward ref is a technique of passing through or forwarding a ref from a child to a parent component. You'd not be using this hook so often, but in some cases where a component is being used as a primitive, say for example, if you're building a UI library and you may need to get access to DOM nodes and then pass them or forward them over to the consumers. Here's where this hook can be used inside the child component for customizing on the ref value before passing or forwarding it to the parent component. Let's get to the demo. Here we have a fancy input example, which is a low-level component that's being used by our app here. We have two buttons, focus and blur. Clicking on focus will focus on the fancy input element, and blur will unfocus it. Let's see how our code is implemented here. The fancy input component is using UseImperativeHandle to customize on the instance value that it wants to expose to its consumers. It takes in a ref passed through by its consumer as its first argument, and a function as a second argument that customizes on the ref before sending it back to the consumer. So now consumer component uses the fancy input, and all it can use from its DOM is focus and blur. all other DOM attributes of the fancy input are hidden from this component. So this is a fancy input example, which is another component that's using the fancy input, and all it can use from the ref is blur and focus properties. Now we have reached our last hook of the day, called UseDebugValue. This hook is used to display custom labels using custom hooks that can be useful when debugging in the browser using React DevTools. It takes the label as its first argument and an optional second argument, which is a formatter function. The formatter function only runs when inspecting through the DevTools. Here's an example that's taken from React's website, which has a custom hook called useFriendStatus. It uses UseDebugValue and sets a label called isOnline for a custom hook. Now, if you look in the React DevTools, it would appear along with your custom hook like this. Friend status, and if you see the label here, online. And you can add multiple such debug values. Do hooks replace Redux? Short answer, no, not really. Hooks are an alternative to React classes and render props. They allow for shareable state logic and accessing context, but hooks don't necessarily replace Redux, mainly because of the ease of features that can be had with it. For example, time travel debugging, if you're implementing features like data persistence, having a single source of truth for holding your application state is a plus one. And having popular support for side effect libraries like Thunk and Redux Saga are not very readily available with hooks. And that's the end of my talk. Thank you all for listening. Now, this is my contact information, and you can find me on LinkedIn, Twitter, GitHub. And if you wanted the link to the presentation, I have posted it here. And that's it. I'll let MK open the floor for Q&A.
Great, thank you so much. Does anybody have any questions at this time? Feel free to submit them via Q&A. Additionally, I will send out Rachita's contact information as well as a link to the presentation. But at this time, if anyone has any questions, feel free to submit them in Q&A, and we can go ahead and get those questions answered for you all. All right, one question in from Benny. I love the presentation, but could you please explain the title changing slide again, displaying the count question mark?
Okay, so I'm guessing you are talking about the UseEffect slide. So that basically shows when the UseEffect runs. So we had a count which would update each time we would click the button. And in that component, we would have a UseEffect that would run after the state of the count updated. So whenever the state updates and the component re-renders, the effects run. So that's why if we had a UseEffect inside that component, it would run after every state update. So when the count was 1, the UseEffect would run and update our document title to having the new value of count 1. And then if it started incrementing the count, it would again run the UseEffect and update the document title. So that's what I was showing, like, hey, the count value is increasing and the same count value is getting reflected in our document title, which I showed using the console log
Great.
I hope that answers your question.
She says, thank you very much. All right, a second
My
question
pleasure.
just came in. Should hooks completely replace using class-based components?
That's a good question. I think there is nothing that hooks cannot do that the class components could. So yeah, but there might. So and also you can use hooks alongside class components. So there's I think there are advantages to using hooks, and if you wanted to, you can start using them in your app alongside class-based components, because there's nothing stopping you from doing that. So probably yes.
Great, thanks for that response. And another question just came in. Would you use UseReducer in an application that uses Redux, or is that not realistic?
So I think when you use React state, when you in an application, when you use Redux, you use that for storing the application state. Whereas when you use the state of given by React, you would store the component state. And that's how you differentiate between the component state logic and the application state logic. So I think it would be the same in this case, where UseReducer of React would still have the state of the component, and you would have your application state in Redux reducer. Because in Redux, it's anyways not recommended to use both the React state and the Redux state together.
Great, thank you for that response. And another question just came in. Can we pass the information between hooks?
I'm guessing that means that can we pass any value returned from a hook to another hook? Yes, you can. So this presentation only was about how to use and build hooks in React components, but there is another aspect of hooks, that is that you can create custom hooks, and custom hooks can use, other custom hooks or built-in hooks. And so, yes, you can use the value returned from the hooks inside other hooks.
Great, we hope that answered your question, Priya. Does anybody have any other questions at this time? You can either throw them in the chat or you can submit them in Q&A. Where will you post the slides again? New on here. Yeah, so for all the attendees on with us right now, I will be sending out an email tomorrow with contact information as well as a link to the slide. And anyone can access the slides. Is that correct, Rachita?
Yes. So it's posted on my GitHub. I will send a link out to MK, and you can convey it to everyone. Yeah.
Yes. Yes. So that'll be coming out to an email tomorrow, probably tomorrow morning, a link to the slides as well as Rachita's contact information. And we have another question that just came in from Dylan. What are some of the top mistakes and pitfalls of hooks beginners?
That's a good question. Make sure that you're following the 2 rules of hooks, that you're calling them at the top of the function component. And the biggest one that I've seen is that with hooks, folks are not able to differentiate between the normal function and hooks. Hooks should only be, I think hooks should be kept separate for just using and sharing the state logic and not just writing utility functions. So for utility functions, you should just, you should figure out if you should use a hook for that purpose, like when you're building an app, or if you should use a normal function. If normal function can do the job for you, then just use the normal function. Use hook only when you are doing something with React component and you want to update the state reactively, or use some effects, or make the UI reflect those changes.
Great. We hope that answered your question, Dylan. Another question just came in. Do you have any recommendation or resources for gaining more experience incorporating hooks within code?
I think React's website is a great resource that you can use for starting with hooks. It explains quite nicely every hook, and then you can search online for resources. There are some good egghead courses too, which you can take, but I'm not sure if they're free. But definitely, I think search online and you would find some resources out there.
Great, thanks. And thank you everyone for all of your great questions. Before we wrap up, does anybody else have any other questions at this time? There are vast tutorials out there. Are there any you would recommend aside from the React website?
Let me see. Yeah, I mean, like I just started writing component and hooks using the React's website, and yeah, nothing that comes to mind as you know, you can go through Dan's blog or Kenzie.'s blog if you're like hitting the ground and not able to you know, figure out something. They have nice articles on UseCallback and UseRef, and you can get some code idea from there. It's called overreacted.io.
Overreacted.io. Yep, I can type that up. And another question just came in about your beautiful presentation. Dylan says, what tools did you use to make this presentation? I like that it swapped parts of the code.
Yeah, so I've posted the packages I've used to make the presentation at the end of my slide. It's using MDX deck and Code Surfer for displaying the parts of the code. That's using Code Surfer.
Code Surfer, that's great. Yeah, and so as Rachita just said, on the last of her slides, there's a link, I believe you said, to the resources for how to build out that presentation. Great. Appreciate you providing those as well. Does anybody else have any other questions at this time? I'm not seeing any questions, but I'm getting a lot of great feedback in the chat. Everyone says, thank you so much. Valuable insights, a great lesson, super helpful. So on behalf of Women Who Code, Rachita, thank you so much for being here with us tonight. Everyone here tonight, please give a big thank you to Rachita, and be on the lookout for an email from me tomorrow with resources from this webinar.
Thank you, MK, for giving me the opportunity, and thank you everyone for listening in.
Absolutely, great. Thank you so much.
Thanks. Bye-bye.